Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in textbooks. How does classical compare with statistical thermodynamics? Classical is what you see from experiments. Statistical is the average behavior of large groups through repeated experiments. So we're just going to base on math based on repeated experiments for statistical. We can dive in a little bit deeper. You can pause the video and read the paragraphs yourself. We're just gonna go through briefly and just talk about each, what are these bullet points? So for classical foundation, so it's what you see, laws, it's the 4 laws, so 0, first, second, and third. 0 is temperature and thermal equilibrium. First is conservation of energy, so that's energy is not created nor destroyed, it is only transformed. It's one of those famous ones. Second law is entropy. Energy only goes in one direction. As it's being distributed outwards, it only goes one way. Entropy doesn't reverse, not that we know of, not yet. Third law deals with things approaching absolute zero in terms of temperature. Approach, again, it's what we see, and it focuses more on, I suppose, equilibrium states and phase changes. Applications, heat engines, refrigerant cycles, phase change. Now for statistical, we use math based on repeated experiments from the microscopic level, so it's like the behavior of particles, basically. Cool. Concepts, so it kind of bridges both the micro and macro states. So we're going to use math to figure out what we can't see. Okay. And then the approach. So we just want to figure out things that are beyond what we can see, and some theoretical things. So here they've got like concepts such as entropy, free energy, pressure from molecular properties. Okay, do with that what you want. Basically, it's the tiny stuff that you look inside the microscope and you want to figure out what's happening on an atomic level. But you do that on such a scale that we just use the probability. That's why they say statistics. Use the maths of what the motion and force of the atom is doing, and then we scale that up like for several trillion atoms. Okay, applications, gases, phase change, chemical reactions. Okay, scope, so for the comparison, classical is what you see, and statistical is using math to figure out on a large scale through repeated experiments. So classical is where you conduct the experiment, you write down the data, and statistical is you use maths, like you use statistics to figure things out. So statistics is more in-depth, whereas classical is what you see in front of you. Okay, so like and subscribe. If you want to support me, become a member or drop a super thanks. Share with your friends because this is not in textbook. If you got questions, or if this was helpful, leave a comment below. Until next time, see ya.